Here is the intermediate value theorem. For any continuous function f of x and two values a, which is less than b, if f of a and f of b have opposite signs, so one of them is positive, the other one is negative, then the function has at least one real zero in the interval a to b. Let me show you a picture. Maybe it'll help us understand what this is saying. Here's the graph of a polynomial function, and I'm going to identify just two random points on this curve. And I'm going to say this first point right here corresponds to this a value here on the x-axis, which means this point on the y-axis would be f of a. This point here, I'm going to say that it corresponds to a value on the x-axis, and I'm going to call it b, all right, which just means that it corresponds to the y value, or the function value, on the y-axis, known as f of b. Now, the function says that if f of a and f of b have opposite signs, and that's true here, f of a is negative, f of b is positive, then the function has at least one zero in the interval from a to b, so basically between a and b. And you can hopefully see in the picture that that zero is right there. That's a zero. So, and it doesn't have to be just one. It could be, it says at least one, right? So basically what this theorem is basically saying, if f of a is negative and f of b is positive, or if they just have opposite signs, one of them is positive and the other one is negative, the only way to go from beneath the x-axis to above the x-axis, you're going to have to cross the x-axis at some point to get from one point to another on the curve. And when you cross the x-axis, that gives you a zero. So in the next example or two, the instructions will say prove that there exists a zero in a particular interval. So prove that this zero exists. All you have to show is that when you plug in this left endpoint into your function, you get, positive or negative, and then when you plug in this endpoint, you get the opposite sign. Okay, so if you can show that you're getting opposite signs when you're plugging in these endpoints here, then you have proven that there exists at least one zero, one real zero between those endpoints. All right, here we go. All right, here it is. This is a cubic function, and you have to prove that there is a zero for this function in this interval. So all you have to do is plug in the number 1 and then plug in the number 2 and show that those outputs, those function values, have opposite signs. All right, so here I go. I'm going to plug 1 in. The remainder, we know by the remainder theorem, will be the same thing as g of 1 and will be the same thing as g of 2. All right, so here we go. So this and this, these are the endpoints of the interval. All right, so bring down the 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. This is 0, 0, negative 6. All right, let's plug in 2 now. Drop the 2. 2 times 2 is 4. 1 plus 4 is 5. 5 times 2 is 10. Negative 3 plus 10 is 7. 7 times 2 is 14. And then the sum is 8. So we just showed that g of 1 is negative 6 and g of 2 is 8. These have opposite signs, right? These outputs are opposite signs. That proves there is at least one zero in that interval. All right, because these function values have opposite signs, the intermediate value theorem says that there exists at least one real zero in this given interval. Good job, everybody.